Okay, so today we're going to look at, or in this one, we're going to look at what a function is and what an injective function is. So what a function is first. Here you've got set A and here you've got set B. So in a function, an x has at most one y. So for every input, you get at most one output. You can't put 3 into the function and maybe get a 6 or a 7. For every x value, you get one y value. So this is a function. If b goes to u, c goes to w, f goes to z, that is a function. It doesn't have to use all set A, but every one of these goes to one of those. E could go to z, still a function. But if b goes to u and to v, that is not a function now, because this value, this x value, has 2 outputs. So what does that look like in terms of a graph? These things are functions. Y equals x squared. Y equals x squared is a function. Every x value has one y value. Here's an x value, it has one y value. Here's another x value, it has one y value. Here's an x value, it has a y value. So every single x value has one y value at most. This is a function. Y equals 1 over x. So every x value has, again, at most one y value. So it doesn't matter what the x value is, it has a y value. Now this one doesn't exist at x equals 0, but that's okay. It's still a function. At x equals 0, there is no y value. It's like this A. Up here, it goes nowhere, but that's okay as long as it doesn't go to 2 places. So what doesn't make a function? We call it a vertical line test. So anything that looks like this would be y squared equals x. That is not a function. This vertical line test, it cuts it twice. So not a function. So anytime you get an x squared, it's not a function. A lot of x cubes won't be a function, but some will be. But this vertical line test, again, with these 2 graphs, every single vertical line only cuts it once. Doesn't matter where I put the vertical line, it cuts it once, and once only, or at most once. Here, doesn't cut at all, that's fine. Okay, so what is an injective function? An injective function is that every y comes from 1x. So it's sort of both ways. So if I draw it, b comes from u, d comes from w, f becomes y. It's a function, and at the moment it is injective. But if e goes to, z, and c goes to z, now it's not injective because 2 things are going to z. So basically an injective function is something that is strictly increasing or decreasing. So something like y equals x, y equals x, that is a injective function. It's a function, vertical line test. It's an injective function because you have the opposite as well. It's an a horizontal line test you can use. Things like y equals x cubed. Y equals x cubed. That is injective because, again, you have this vertical line test. It hits it once. Horizontal line test, sorry. If we have y equals x squared, is this an injective function, y equals x squared? No, because it fails the vertical line test or horizontal line test. Sorry, I keep getting them mixed up. This hits it twice. Is it a function? Yep, because the vertical line test hits it once, but it's not injective. something like y equals log x. Now, we haven't looked at that, but we will soon, so we might as well see it. Y equals log x is a graph that looks like this. So it doesn't exist for x equals 0, but it's still a function, and it is an injective function because, again, that vertical line test. This horizontal line only hits it once and only once. So how do you prove that something is injective? So basically, it's like the contradiction test. What it's saying is that for an x value, you get one y value. So let's suppose that f of x equals f of y. So here we've got f of x equals 3x minus 10, and we want to prove that that's injective. So suppose we've got f of x equals f of y. What that means is that 3x minus 10 equals 3y minus 10. Now we can minus 10 from both sides, or add 10 to both sides here. We get 3x equals 3y. Dividing by 3, we get x equals y. And there's that contradiction. We started saying that they were different and equal, but they're the same thing. So from every single value of x, we get only one f of x value. Let's look at this one. F of x equals the absolute value of x plus 3. Is this injective? Okay, let's suppose that it is. Suppose it is injective. In other words, if it's injective, f of x should not, and f of y can't be the same. So x plus 3, the absolute value of x plus 3, must equal the absolute value of y plus 3. Can this happen? Or must this happen for the same values of x and y? In this case, the absolute value of x equals the absolute value of y, and suddenly you've got two things here. If x is 3, y could be plus 3 or minus 3. So you've got these two things happening here. So this is not injective. Not injective. If we look at the graph, because it is an absolute value graph, it cuts at minus 3 and looks like this. So it fails that horizontal line test. There's the horizontal line and it cuts it twice, so it's not injective. This is a straight line. Y equals 3x minus 10 is going to look something like that. It survives that the horizontal line test. The thing with injective functions, they must be strictly increasing at all times, like a straight line or like a y equals x cubed. That's injective. Exponential graphs are injective because they're always increasing. As soon as it dips, then it's not. Or if it's not always increasing, it could be always decreasing as well. So all these lines there, y equals 2 to the power of x, it's always increasing, therefore it's injective. Y equals x cubed, always increasing. A straight line is always increasing, so they're all injective. Okay, thanks for that. Also, Michael has put up a fantastic website that goes through all those things: functions, injectives, injective functions, surjective functions, and bijective functions. And there's a little quiz at the end. So that's probably a good place to start as well. Thanks. Bye.